LoRa or low rank adaptation is one of the finest technique in fine-tuning large language models. LoRa is a technique that enables us to fine-tune these LLMs without the need to retrain them entirely, saving both time and computational resources. As I said, LoRa stands for low rank adaptation, which is a method designed to fine-tune these LLMs in a more efficient and cost-effective way. LoRa leaves the pre-trained layer of the LLM fixed and injects the trainable RAG decomposition matrix into each layer of the model. I have done various videos where I explain it in detail, but for this video, I'm going to introduce you to this LoRa Land by Predibase. Predibase is one of the most impressive companies I have seen over the last few months. It allows you to do LoRa training and serving for LLMs in a smaller, faster, and in a very cost effective way. And I have done a couple of videos on Predibase too, so please search the channel and I'll also drop the link in the video's description. Now, Predibase has released this LoRa Land, which is a collection of 25 fine-tuned Mistral 7B models that consistently outperform base models by 70% and GPT-4 by 4 to 15% depending on the task. LoRa Land's 25 task specialized large language models were all fine-tuned with Predibase for less than $8 each on average and are all served from a single A100 GPU using LoRaX. Now, I did a video on LoRaX 2 weeks ago, and LoRaX is primarily an open source framework that allows users to serve hundreds of adapter based fine tuned models on a single GPU. A really fine technology. I would highly suggest that you should give it a go and maybe follow this video which is on your screen to get it installed locally. And you can even serve thousands of fine tuned LLMs on single GPU. How cool is that? Okay, now having said that, coming back to this LoRa Land, and by the way, whoever has designed this image, awesome work there. Okay, so this collection of specialized fine-tuned models, all trained with the same base model, offers a blueprint for teams seeking to efficiently and cost-effectively deploy highly performant AI systems. And the thing is that with the continuous growth in the number of parameters of transformer-based pre-trained models, or PLMs in short, there is a huge need in order to cut the cost. Plus also it is becoming increasingly challenging to adapt them to specific downstream tasks, especially in the environment which are budget constrained or computation constrained. I'll give you a quick example. Yesterday I was trying to build an LLM based application for a customer in a public cloud. I was trying to provision some of the GPU or accelerated servers in the cloud. I couldn't because there was too much demand, it was not available. If I would be using something like this LoRaX or Predibase and then this QLoRa or maybe some adapters, then it will be easier to use my existing GPUs in order to provision these models. Okay, now having said that, there are a lot of good examples in their blog post too. I'll also drop the link here in video's description. But if you look at this diagram, the thing is that fine-tuned LLMs have historically been very expensive to put it into production and serve, requiring dedicated GPU resources for each fine-tuned model. For teams that plan on deploying multiple fine-tuned models to address a range of use cases, these GPU expenses can often be bottleneck for innovation. That is where this LoRaX shines. And with the LoRaX, you can enable the team to deploy hundreds of fine-tuned models for the cost of one from a single GPU. How cool is that? And there are a lot of good stuff which is scattered across this blog post. And as I said, I'll drop the link in video description. You can read further on it. Now, they have also done some evaluation metrics on this LoRa Land model, and they have created this parallelized evaluation harness that sends high volumes of queries to Predibase, LoRaX powered REST API, which also allows them to collect thousands of responses for OpenAI, Mistral, and fine-tuned models in a matter of seconds. And then you can see that in this results from this evaluation matrices, they have put in the adapter name, whether it is question answering, toxicity, and the list goes on and on. Data set, metric, fine tuned, and then some of the results from GPT-4, 3.5, Mistral 7B, and this is a fine tuned one. And you can see that in bold black, the performance of fine tuned one is awesome. It has even beaten GPT-4 by a huge margin. Look at these figures, amazing stuff. And if I scroll down, then you can see that, for example, even on this wiki SQL, which is seems to be very similar, and you would thought that GPT-4 will outperform everyone else, but you can see that even this has won in that uh, task too. Amazing stuff, beautiful. Look at this legal clause classification. Look at this number. Look at GPT-4's number. Amazing stuff. Look at this one, news topic identification from DBpedia. Outstanding. Okay, now this is what LoRA Land looks like, where you can select all of your categories, whether you want to do summarization, you want to do topic identification, you want to do explanation, or whatever your use case is. From here you can choose adapter, and then here, and you just type your prompt, you run it, and then you can compare the responses. This is a fine-tuned model response. On the right hand side, it is a base model response. So let's play around with it to see how exactly it works. Let me make it tad bit bigger so that it will be more visible. Yeah, much better. Okay. Okay, now for the first test, what I'm going to do, I'm going to select the category academic benchmark, and then I'm going to just check the maybe answer validation. Now here you can see, once you select the category and then you select the adapter, there are few prompts which you can select from here, or you can put your own. Now one important thing to note down is that it is very important to keep the prompt template intact to make sure you get the optimal performance, because it is adapters are highly dependent on that. Now instead of using their prompt, let me put in my own. So I'm just going to first put the question in. Let me put the question. So what I'm going to do here, I'm just going to replace it with this. So I'm asking it identify the common core standard that this passage best supports, and then there is a passage from some of the text I have. So once that's done, I'll also put in some of the response just to give it bit of a help. There you go. Now let's see if it is able to detect that. Click on run, come down, nothing. So you can see that it is not returning me it, so it has returned me 0. So what it means is that if the response is correct, then return 0, otherwise run 1. So you can see that these are my correct ones, so it has detected correctly, and both of them have done well. Now let's select one of their own. So let's select what type of flower, and then click on run. So fine-tuned one has returned correctly, whereas base model response was unable to detect it properly. Good stuff. Okay, now let's try out one more category from here. Let me see. Maybe we could go with topic identification. Now, instead of this, let me put in my own one. So I'm asking identify the main topic of this news article, and then let me give it a news article here. There you go, this is my news article. And then let's see if it is or maybe I'll, instead of there, how about if I put it in the response just to see what it does. I like to confuse the models. Let's try out here. Let's run. So 0 mean that it properly answers the question. Now it would need, yeah, so it was unable to do it, whereas the base model was unable to do it. Fine tuned, return 0. Good stuff. Okay, and let's try try the maybe new. This is a good one. Okay, let me try again. Okay, so again the title, I'll just say identify the main topic, or maybe I'll just put the passage in and then try it out. How is that? So I'm just putting in the body the whole passage, and then I will just give it a topic like mm, what should be the topic? Maybe I'll just give it random one. Efficiency. Okay, let's run it. Okay, spelling. Okay, run. Let's see. So it says 0, whereas the base model says the article type is science technology. Very nice. Good stuff. Now let me say if I just randomly say tennis, what does this done? Okay, still that is good. Awesome. So you can see that how cool it is to try out different adapters from here. And then if you want to know more detail about these adapters, you can read from here. There you go, by just clicking on it. As how many number of rows in the data set, training time, hardware, and there are a lot of things. As I said, I will drop the link to this in video's description. Play around with it and let me know how you go. But all in all, as usual, again, a really fine tool from Predibase. If you have any thoughts, please share them in the comments. And if you like the content, please consider subscribing to the channel. And if you're already subscribed, please do me a favor and share it among your network as it helps. Thanks for watching.